Hello, everyone. Welcome to our LinkedIn Live session today on Halloween. Happy Halloween. So today's session is called Understanding ELT, ETL, and Reverse ETL Pipelines and where Snowplow fits in. We'd like to thank everyone for joining live today. And I will be introducing John Sue, our speaker. He is a solutions architect at Snowplow, and he will be running the presentation today. I'll let him introduce himself a little bit more in 1 second, but please just keep in mind that this session will be recorded and available to rewatch on our LinkedIn Live page, on our LinkedIn page, and also on our YouTube page, and also through our website. So please keep an eye out for all of that. So if you have to drop today, you can finish it on your own time elsewhere. So let me pop John in to introduce himself and get the presentation started today.
Hey everyone, thanks for joining us live. So my name's John and I'm a solutions architect here at Snowplow. And what my role essentially involves is working directly with our customers to help them implement best practices out of our Snowplow BTP platform. So that's everything from getting their initial pipeline set up to running their tracking design and implementation and building data models, as well as any use case downstream activation. Cool. So I guess to kind of kick off today's webinar, I think we're going to first just start off by really defining what the difference between ETL, ELT, and reverse ETL is. So for those who don't know, ETL and ELT are essentially two different data processing approaches for essentially moving raw data from a source system. So when we're talking about source systems, we can think of things like websites, apps, a SaaS tool potentially, or third-party platforms like ads, for example, for marketing teams. So we're essentially moving that data from that source system to a destination, and the destination would typically be like a data warehouse or data lake. For ETL and ELT specifically, they both involve the same steps, just in a different sequence. So ETL and ELT are essentially acronyms. So the E stands for extract, which is really about how do you collect raw data from your different source systems. And that could be structured, unstructured, or semi-structured format. It doesn't really matter. But like, how do you extract that data from a potential system? And then you move it to like a transformation step. So a transformation step is essentially where you're now focused on changing that raw data from its original structure into a format that meets the requirements for any downstream analytics as you need. And then the L stands for load, which is essentially where you're storing that data in a destination, which could be a data warehouse, a data lake, or a lakehouse architecture, depending on how you instrument it. So if we start with the ETL, so extract, transform, load paradigm, that's a very traditional approach that has been around since the 1970s. And it's essentially where you first extract the data, you perform some transformation like data cleaning or data validation before you actually load it into your target destination. It tends to be better suited for more structured data. So that's essentially any data which you can represent in tables with rows and columns, as essentially that transformation process before you load it into a warehouse usually involves you having to transform one set of structured data into another structured format. So one of the constraints with an ETL approach is the issue is if you have 100 different source systems of where you want to extract data from, you basically have to write custom ETL processes individually for each data source. So if a team, for example, wants like another data source ingested into a warehouse, what the data team would essentially have to have done in the past would be to write a new process to basically extract that data first before they can actually store it. So it adds a lot more time to maintenance as well as the time to value for that data itself. So the other paradigm that we also mentioned was ELT. So ELT is a more common trend that basically emerged since Redshift was launched and adopted in 2012, where essentially now companies now have this easy access to computing power, which they previously did not have. So with these cloud data warehouses, because the computing power can scale on demand, the modern standard has now moved to this ELT approach, which is extract, load, and transform. So with the ELT approach, the difference is you still extract the data from a source system, But what you do is you load that data in its natural state into a data warehouse or data lake. And then once it's actually stored in the destination, you then perform any transformations or data modeling as you need within the warehouse. So taking full advantage of what a data warehouse can do for you. So the key differences between ETL and ELT. So the first one is the order of operations. So essentially where you do the transformation. So for ETL, you transform the data before you load it. And for ELT, you load it first, then perform transformation. ETL also tends to rely a lot more on external tools to transform the data before the warehouse. With ELT, because you're leveraging modern data warehouse capabilities, you can essentially just dump all the data inside the warehouse and then perform the transformations in the one place. You would then also find that ETL tends to be slower, as you need to perform the transformations before you actually load the data. While with ELT, because you're essentially loading the raw data immediately, the time it takes to actually get the data into the warehouse tends to be a lot quicker in terms of processes. So now that we've talked about the differences between an ELT and ETL approach, let's just quickly touch on some of the key benefits. So the benefit of adopting an ELT approach over an ETL is that you can essentially just load all your data into the warehouse or lake, and you don't actually have to worry about what structure or format that data is in. You basically can just extract it, load it into the warehouse, and then from there build any transformations on top of it. This helps simplify the pipeline process because you essentially don't have to write all those custom ETL processes which are described for each data source, and you can have one method of basically just extracting data regardless of where it's coming from, and then you perform transformations as needed. Because the second benefit is because you are performing those transformations in the warehouse, it does also allow for greater flexibility, performance, and scale, as you don't have to do all this complex pre-processing as what you would typically have had to do previously with an ETL approach. And the third but not last benefit as well with an ELT approach is it supports a more self-service data organization, as analysts and data teams can now essentially access and perform their own transformations on that raw data without being limited by any logic that has been implemented by upstream extract processes and constraints. Cool. So now that we've kind of touched quickly upon ETL and ELT, the next thing I just quickly want to define is what is reverse ETL. So regardless of what the difference is between ETL and ELT, the end goal is the same. It's about getting data into a single location, typically a warehouse or data lake, where you can start structuring, joining, aggregating different data sets together to create a centralized data asset, which you can then use as a source of truth for your organization. Inside this source of truth, you would typically have all your business core definitions defined once, and then you would have all these different data sets stitched together, regardless if they're internal or external. And the whole concept of a data warehouse is, you can move all these different data sources around your organization and use them for different purposes. So it could be things from like analytics and BI reporting to more advanced, ML and AI use cases. But the problem is, once we have that single source of truth in the data warehouse, because now we have this really pretty unified data set, what you ironically have now created is essentially a silo around that data, because now you're unable to actually operationalize it in external tools. So this is where reverse ETL essentially comes in. So reverse ETL is essentially the process of sending that transformed and high quality data that you already have in your data warehouse to a destination business platform. So that could be things like a sales CRM, an ad platform, or even an application database, so that downstream users can essentially use that data that you have already stored in your warehouse to create some form of business value and get some action out of it. So the reason that we want to use reverse ETL is you're essentially putting the data where the operational work happens. So when we think about businesses that interact with their customers, it's not usually in the back end, in the warehouse. It's usually on that front end. So it could be a sales team, a marketing team, a customer support team, for example. And reverse ETL is about getting the data from that centralized location into the hands of the actual teams that are interacting with your customers. So for example, for marketing teams, they may predominantly spend a lot of time in a particular ads platform. So reverse ETL is one way of how they can move that data from the warehouse into the hands of downstream business users. And it also provides this mechanism which enables data automation so that if anything changes in the source of truth in your warehouse, business users don't have to manually update any fields that they have pushed out into that destination system. So once Reverse ETL kind of kicks in and pushes the data from your internal environment into an external third-party platform, you can then use it for like a range of different use cases. So common use cases could include like in-app personalization, specialized target marketing campaigns using audience segments. You could reduce churn through customer support, or even optimizing any internal operational processes that you may have, such as fraud detection in a new real-time way. Okay, so now that we've kind of defined what ETL, ELT, and Reverse ETL are, I guess what we'll now want to talk about is how Snowplow fits in to all to these different paradigms. So Snowplow is what we refer to as Customer Data Infrastructure, or CDI. And at its core, CDI is really about software that has been designed for ingesting, governing, and delivering behavioral data to serve all parts of an organization, regardless of what team they belong to. So there could be a use case for the product team, one for the data science team, even the finance and customer support team can use the data that has been generated by our CDI infrastructure. CDIs have now kind of become this really popular trend in the industry because they kind of play hand in hand with composable CDPs, as essentially they are both underpinned by the core technology of a data warehouse or data lake, and allows for a more flexible and scalable customer data solution than traditional packaged CDPs, helping to reduce things like silos around your data, or even tech debt in terms of maintenance, especially in today's world where your use cases are starting to become more advanced. So when we're talking about where Snowplow fits in with ETL and ELT, it actually supports and fits both paradigms quite neatly, because at its very core, Snowplow is all about giving businesses the ability to create and collect behavioral data about their customers in the most granular way possible. But Snowplow doesn't just want this data to only be the most granular. We also want it to be of the most high quality and the most enriched it can be. So basically, as part of the Snowplow pipeline, what we have is, so we essentially collect the data from a source. We then also perform transformations on the data, which includes validating the event to ensure it meets a predefined schema, as well as has enrichment, where essentially what we're doing is we're doing dimensioning widening and enhancing that behavioral event with extra properties and values attached to them. So that's kind of can be imagined as a mini ETL process, because we're essentially still collecting data. We're doing some mini transformations on it before loading it into like a destination warehouse or lake. But then once it has actually been loaded into that destination, that modern ELT paradigm can then kick in, and then you can perform any transformations and more robust data models on top of the data directly inside the warehouse or on top of the lake. So the next thing I just want to quickly talk about also is around real-time event streaming and reverse ETL. So the majority of ETL processes, so they're the ones where you transform the data before you load the data into a warehouse, have typically been traditionally batch-based. So when it's batch-based, it essentially means we process the data in batches at set intervals, as opposed to continuously streaming it into the warehouse or lake. In the real world that we live in, this isn't how it always works. So if we imagine whenever a customer interacts with a business, this always happens in real time. So now what we essentially have is this disconnection between what is happening with a customer in the real world as they interact with you as a brand, and our behind the scenes data processes. So on one hand, we have a customer performing some sort of action on a website. So say, for example, they may have browsed a particular product or purchased something. And on the other hand, we may then have our operational systems waiting to receive that latest information about the customer. So because of that disconnect in time with a batch process, what this essentially creates is bottlenecks around how quickly businesses can essentially respond to that latest contextual behavior data about a customer and take whatever the next best action for that customer may be. So how does Snowplow help enable businesses to overcome these challenges? Well, it's really all about getting the data from a certain point in time from a customer, so an action on a website or app, and then getting it as quickly into the hands of downstream applications, and which could be making it available in a data warehouse or data lake or into a third-party application as soon as possible, so that you can take some immediate action based on the latest behavioral data. So the way that Snowplow enables real-time event processing or streaming capabilities and ensure that businesses can have access to the fresh data as soon as it has been generated by a customer without delay, there's essentially two ways. So the first way that we have is a near real-time delivery into a number of different data warehouses and lake houses, such as BigQuery and Snowflake. This essentially means the time it takes between an action happening on the website to the time the data actually lands in your warehouse is minimal, and you can almost immediately run your data models on top of that data, and then use a traditional reverse ETL tool to kind of batch process and forward that data into your downstream applications. The second option is, if you don't want to wait that long for it to actually land in the warehouse, is that you can do real-time event streaming, which happens even earlier in the Snowplow pipeline before it even lands in the warehouse. So the way we do this is we essentially, when the data is collected, it basically gets pushed into a real-time event stream immediately. And then depending on where you have deployed your Snowplow pipeline, this could be a Kafka, Kinesis, or PubSub stream. And then what you can essentially do is read events from that real-time stream and push it out into another destination without it even landing in the warehouse. So there's two ways essentially how Snowplow can allow you to read from that real event stream. So the first way is you either build a custom script or app that reads directly from that stream directly, perform some logic, and then take some action on that event data in real time. The other option that we also offer is we have a tool that is built in Go called Snowbridge, which is essentially a low latency tool, which understands that Snowplow structure, and you can basically replicate that stream of data to external destinations and then send that data in real time to basically any platform that supports HTTPS, or even forward it to another Kafka, Kinesis stream or topic as well. And something important to also note about is, if you are tapping into this real-time event stream that we offer, it contains events that have already passed validation, which means it's of the highest quality. And it's also gone through the enrichment process, which means it's been made as rich as possible. So it's all this high quality and rich data that you're actually using in your downstream applications. And then the data that you read from that real-time event stream actually matches the same data as what you get in the data warehouse as well. So essentially, by being able to tap into that enriched event stream in real time, what businesses can now essentially do is power a number of different advanced use cases. So they can do things like dynamic pricing, product or content recommendations on site, do fraud and anomaly detection, and it allows businesses to really move at this fast pace and essentially create this flywheel effect where you can essentially push behavioral data about a customer when it's collected downstream through your systems really quickly, take a next action, regenerate even more behavioral data, and then feed it back into the system again, which is this really powerful way of how businesses can unlock and build a sustained competitive advantage. Cool. And so the last bit of what I want to cover is essentially how Snowplow is really flexible and can scale with CDI and pipelines at every stage. So essentially, Snowplow sits at the heart of the modern data pipeline. So it does everything from that collection of the data to processing it to operationalizing that customer behavioral data, while supporting both traditional ELT and ETL use cases, as well as more advanced real-time streaming as well. So there's four key capabilities that Snowplow does really good. So the first one it does, because you're essentially collecting data from multiple sources and putting it into a single location in your warehouse, it allows you to easily unify your customer behavioral data with any operational backend data that you may have. And it integrates seamlessly with your existing data architecture. So regardless if you're using a data warehouse or data lake, if you're using a batch or stream processing paradigm, Snowplow essentially just slots into your existing architecture. And we basically meet our customers where they are, as opposed to you having to massage your architecture to fit with Snowplow. The other thing that Snowplow's pipeline has also been designed to do is scale effectively to handle large-scale event data, regardless of the volume. So regardless if you only have millions of events each day, or even billions, the Snowplow pipeline can scale up and down as needed, and businesses essentially only pay for what they need and use, especially, which is really important at large volumes of data because it gets really expensive. The third capability, which I also mentioned on this webinar, is real-time processing. So because it's now possible to access data as soon as it's been generated through hooking onto that real-time event stream without any delay, it ensures there's this minimal delay between the customer's action on site to the data actually being made available downstream for another use case. And I guess the last but not least, or one of the most important things actually, is really around this concept of data quality. So Snowplow is a real advocate of the shift left approach to data quality, where essentially we believe that data quality is a really critical foundation for every data use case because of, garbage in, garbage out. And what we are doing essentially is push a responsibility for data quality upstream to data producers. So because we're collecting data directly from a website, app, or IoT device or some other source system, this is like the earliest stage in the process of where you can start performing validation and quality checks. And we ensure that any data that we are actually collecting is first validated before it even hits your warehouse or lake as part of that ingestion. And what this allows teams to do essentially is spend less time on cleaning up the data downstream and actually start to spend more time on making use of the data and getting actual business value out of it. So that's pretty much all I wanted to cover today. Are there any questions?
Hi, John. Thank you so much. We will go through some questions that, if you don't mind me asking you. And yeah, if anyone watching has questions, please make sure to comment and we will address them as we go. We have a few minutes here, so I'll just go ahead and start if you're ready, John.
Go ahead.
Okay. How do companies decide between ETL and ELT? Are there specific data scenarios where one method clearly outperforms the other?
Yeah, good question. So I don't think it's a matter of choosing one over the other, just because they both have like their own very specific advantages and disadvantages. And it really comes down to what you're trying to achieve or what type of data you're interacting with. So just as like a rule of thumb, so ETL, so basically where you transform the data before you load it into a warehouse, it tends to be better with structured data and smaller data sets that might require complex transformations. While ELT, on the other hand, it's really good with dealing with massive amounts of structured and unstructured data. So that's kind of like the first consideration. The second consideration would also be like how quickly you need the data available. So ELT tends to be more suitable for real-time and near real-time analytics, because what you essentially do is you're loading the data and letting a downstream system actually have to do that processing. While with the more traditional approach of ETL, you essentially have to do quite a bit of extra overhead transformations before you actually load it. And then also even things about like compliance, for example. So with ETL, you can basically redact any insensitive information before you send it into a warehouse. While with ELT, you're essentially pushing all your raw data into a warehouse before you do that compliance check. So it really depends on the use case, I guess. Yeah.
Awesome. Thank you. And if you have specific questions for John or a specific use case that you want to discuss, feel free to get in touch with us and get in touch with John and connect with him on LinkedIn. Happy to answer those specific questions. Okay. And then another question for you, John. When using ELT, and you were touching on this, are there common challenges with loading raw data directly into the warehouses without pre-transformation?
Yeah, sure. Okay. So when you're using ELT to load data into a warehouse, because you're loading it directly, so at the source where you're extracting the data, that data will have some sort of structure or schema already. And if you're loading it rawly directly into a warehouse, what you have to be careful of is making sure that whatever structure in that source data also matches whatever structure that you have in a destination table. So making sure the schema between that source and destination matches. and which is a really hard thing, right? Because like the data structure can change over time. So what Snowplow actually does is we have these schemas. So essentially what any warehouse loader that we have is we basically handle any differences, and it detects any differences in schema change and evolution, and it updates the destination table accordingly as your source app kind of like changes as well. So make sure that, you're not trying to fit like, a circle into like a square, for example. So it's making sure like it's compatible on both sides.
Great. And we actually have a question from YouTube. So I want to make sure we can get those through. So when you talk about Snowplow allowing to operationalize behavioral data, I see downstream connections only towards DWs. Does Snowplow offer ready-made ways to extract values when data is moved there?
Sorry, what was that downstream app that you mentioned?
I see downstream connections only towards DWs. I don't know if
data warehouses.
Yes.
Okay.
Yeah.
Yeah. Okay. Yeah. Data warehouse. Okay. Cool. Yeah. So yes, we can operationalize it in real time. So essentially, the Snowplow pipeline consists of multiple steps. So it basically first collects the data, it performs the validation, it does an enrichment, and then it loads it into a warehouse or lake. So that's the typical flow. So with the real-time streaming, essentially what we do is before you actually load it into the lake, in that enrich step, so basically once you've kind of done enrichments on the data, it basically will push it into like a stream of messages in real time. And what you can essentially do is use Snowbridge to hook onto that event stream and then read messages as they come through that enrichment step. And then instead of just falling it into like a data warehouse, what you can do is you can basically use Snowbridge to send it to any HTTPS endpoint. So most operational applications or SaaS products or tools, they tend to have like a webhook available, and you can essentially send those events into that webhook.
Lovely. Hopefully that answers your question. And then we have a few minutes, so I want to get to some other ones. Again, if you want your last minute questions answered, we have a couple minutes, so please send those through. John, for you, from my end, can we talk about how Reverse ETL enhances operational efficiencies? And are there examples of where this process has unlocked value in marketing or customer support?
Yeah, sure. So Reverse ETL, it's really about breaking the wall between that proprietary data that you own in your warehouse and then getting it into the hands of your operational teams as quickly as possible so that they can take some form of action usually, and which usually translates to some sort of business value out of the data, as opposed to just having the data sit in your warehouse for eternity. So if we're talking about marketing, like a very basic marketing use case might be, you might want to segment your customer database to basically personalize that customer experience along the customer journey. So for example, if we know a customer has done, action X, Y, and Z on his website, for example, you then immediately automatically follow up with like a unique corresponding action that matches their current intent in a single moment of time. And something quite good to note about, I guess, Reverse ETL is those use cases don't just exist online, and they basically extend beyond that digital realm and can be brought offline. So if you imagine if you're like a retailer business that has physical stores, if you can see what products a shopper has previously browsed online, or what their purchase history is, or even what their shopping preferences are in terms of like their wish list, and if you can create that single customer 360 view, and then if that shopper then goes into like a physical store online, what your employees can essentially do is use that behavioral data that you have collected about them online, and then you can use that to tailor their offline shopping experience as well. So essentially what you're now doing is you're connecting that online customer experience with the offline customer experience to kind of build this 360 experience or next gen shopping experience.
Love it. Awesome. Thank you. And we're at 12:30 EST. So we'll stop there. Just if you have any other questions, please feel free again to connect with John or follow us, Snowplow, and we're happy to connect you to team members that make sense. And yeah, I want to thank John for a great presentation today and for joining us live on Halloween. And yeah, thank you so much, John. And remember that you can watch this again through our YouTube, our LinkedIn page, events page, or our website. So if you want to register for any upcoming events, please scan this QR code. And yeah, we'd love to see you at future events. And thank you, everyone, and have a great day.